Everybody, you recognize this guy. This is rulers that you've been using in school as soon as it focuses. Since you've been in school. Here it is. Woo! Okay, notice it has two sides. Okay, it has inches on the bottom and metric on the top. You'll always, or if you turn it this way, now the metric is on the bottom and inches are on the top. In this class, you will always use the metric side. There's no excuse to not use metric. You should always be using metric. Okay, there's, again, no reason not to use metric. And there's lots of different types of these rulers. There's this sort of thing, and then the good old-fashioned one, this standard wooden guy. Okay, so, but whatever. What we're going to do is I'm going to show you how to use a ruler to get the most significant figures you can out of it. Now, most of you know how to use a ruler. You line up something and you're like, oh, okay, this thing is about this long, and for everyday use, that's fine. But in science, you need to be a little more precise, and you need to have, you need to have as many sig figs as you can get out of a measuring device. And so we're going to spend a little time showing you how to use a ruler for science class, and then after that we are going to I'm going to probably show you another piece of glassware so that you can do because the ideas that I show you with the ruler will extend to any piece of glassware that's not digital. Okay, so let's get started. Here, I'll show you an example. So I have my trusty wooden ruler here. Okay, notice I am on the metric side. Now I picked this ruler for a couple of reasons. First of all, if you look, it's labeled, it has a scale that says mm. That's millimeters. Okay, millimeters indicates that each one of these little hash marks is 1 millimeter. Okay, that doesn't mean that this number is 1 millimeter. That is actually, if you count them up, 10 millimeters. So that's actually a whole centimeter. So the big numbers typically on these rulers always represent centimeters. So that's 1, 2, 3. This actually, on your screen, you can see it goes up to 16 centimeters. It goes beyond that. It goes just past 30 centimeters. But don't get confused there. Some of these will actually say centimeters on it. You see that nice green one? It says centimeters. And then this one's kind of neat. It says millimeters, but it actually has 10 because that's 10 millimeters. So you see lots of different types of rulers, but this is primarily the type of ruler that you'll have in class. Okay. Now, when you go to measure something like this line, okay, now I'm going to try to do it right from the screen so you can see me. Okay. Now, when you do this, my guess is when you measure this line, you're going to look over and you're going to be like, okay, 1, 2, 3, 4, 5, 6. It's 6 something centimeters. It's like 6, and then you look at where it ends, and it's like, okay, 6 point, and this middle one is 5, 6, 7, and then it looks like it's like 6.8. Okay, 6.8. Let me write that in a place so you can see it. 6.8. Okay. Now, most people would stop there. But the beauty of significant figures is you estimate the last decimal place. Okay. You estimate, it doesn't have to be a decimal place. You estimate the last number. So you have the numbers that are certain, like 6 and 0.8, because you can read them right off of the ruler, and then you estimate, because it's not scaled, the last one. So I look at that, and as I stare at it, I see that it doesn't fall exactly on the 0.8. It actually falls just beyond it. So I'm going to estimate that that is 6.82, and then my unit centimeters. Okay, so 6.82 centimeters. Let's try another. So now we have a triangle. I was almost going to say rectangle. That'd be dumb. There we have a triangle, and I want to measure the sides of the triangle. Okay. To do this, again, we put your ruler down. Okay. And then you measure. Okay, so you'll notice that that is about 4. In previous times, you would say, oh, side A, that's about 4. But if you look, it's not actually exactly 4. It actually falls just past the 4 at the between the 4 line and the 0.1 line. So what I know is that this first decimal should be 4.0. We measured it, and it measured to be 0. And then just past that 4, okay, don't get confused with that purple mark there, okay, and I actually think it's about 4.03 centimeters. Okay, I think that makes sense. Now let's measure this leg of the triangle. Okay. Okay, and now this one, even though it appears to be the same, okay, it's not. It's smaller, so it's 3 point. This one looks like it is 7.2 centimeters. Right? Now the hypotenuse. And now before I continue, I do want to say, when I measure the hypotenuse, I am not putting it all the way to the end of the ruler. I'm not putting it here and saying, okay, let's measure it. I am actually starting my measurement by putting the edge of the line with the 0 mark on the ruler. They always put a 0 mark on a ruler, so in case it falls or something happens, you can actually see where you should start your measurement from. Okay, so now I measure this side C, okay, and I'm going to say, well, it's 5 something, okay, that's 1, and then it's, okay, 5.4, and then it is, let's see, 5.42 centimeters. Okay, so I think that tells you what you do. Now, that last place is always estimated. You may estimate different than me. Okay, so 5.43, maybe you measure it again, and maybe, your lab partner comes along, somebody that is slightly different from you, and that is 5.45. Okay, now in science class, when you do this and you measure that, that's okay. It's okay to have numbers that are slightly different in the last decimal place, because people measure things differently. Okay, so the last place is always going to be estimated. So there are certain digits, these guys, okay, and then there are the uncertain or the estimated places. In this case, it's always, in the case of singular figures, it's always the last place. You always estimate one place more than what the measurement gives you. Okay, so now let's extend this to other pieces of glassware. Okay, so I see a graduated cylinder. This is a 10 milliliter graduated cylinder. You can see the 10 at the very top. And here's what we do, again, with the bell's ringing. It's going to ring a bunch of times between now and when you're done recording here. Remember, you have to estimate another place beyond what you can measure. So in terms of, you can see that is going to be 7 milliliters. Okay, if you want, you can pause the video and try to figure out how much that is, what my measurement comes out to be. But I'm going to explain it. So, and then that curved line right there that you see, it's curved. It's called a meniscus, and that happens because of intermolecular forces in the side wall. The water is actually climbing up the side of the wall. So what you want to do is you want to read to the bottom of the meniscus where the water isn't climbing up the side wall of the container. Okay, maybe it'll be a little easier if I do that. Okay, and so now you can really see where the meniscus hits one of those things. Now, what I see is that measurement is 7.3. But notice it's between the 0.3 and the 0.4, okay? So we estimate the last place. I would say that measurement is 7.31 milliliters. So anything that has graduations on it, that has lines, you can use this same method to get the right number of sig figs out of it. So a ruler, a 13-cent ruler that I get in my thing, that thing can get 3 significant figures. This graduated cylinder can get 3 significant figures, which helps when we are trying to do calculations. So that's how you get the right number of significant figures out of measuring devices.